Okay, well, in this video, I am going to discuss the Pythagorean Theorem, which is probably something you've seen before in geometry or other classes. And it just talks about the relationship between the length of the sides of a right triangle. And you can see in its full glory, all written out. It says if A and B are the lengths of the legs of a right triangle, and C is the length of the hypotenuse of the triangle, then A squared plus B squared equals C squared. Okay, it's a lot easier just to look at the picture, the more visual version. Of course, the legs are the shorter sides, and the hypotenuse is the longest side, and the legs are at right angles to each other. So if A and B are the lengths of the legs, and C is the length of the hypotenuse, A squared plus B squared equals C squared. This has been around for like 4,000 years. It was back in ancient Greece. It was proved by Pythagoras, but actually I think it was proved by someone else in his little cult. But anyway, this is how it is. We're probably familiar with it, and we see with this example of a 3-4-3, a 3-4-5 right triangle. We can certainly check that 3 squared plus 4 squared equals 5 squared. Okay, because 9 plus 16 certainly equals 25. So that works. So in this way, if you're given the length of two sides of any right triangle, you can use the Pythagorean theorem to find the other side. For example, in this case, we're given this length is 5, this length is 4, and we want to find the length of the hypotenuse x. So we write to it. So in this case, 5 is A, 4 is B, and x is C. So we get 5 squared plus 4 squared equals x squared. And we get 25 plus 16 is equal to x squared. And if we add these together, we get 41. And we just take the square root of both sides. And in this case, we only take the positive square root, right? Because it doesn't make any sense to have for a triangle to have a negative side to have a negative length. So you have the square root of 41. You don't have to take out your calculator. The square root of 41 is obviously not a nice integer, so you can just leave it like that. Okay. If we wanted to do another example, in this case, x is the length of one of the legs. So, and 10 is the hypotenuse. So we can write x squared plus 3 squared is equal to 10 squared. And then x squared plus 9 equals 100. You can subtract 9 from both sides. We get x squared equals 100 minus 9. That's 91, I think. And then take the square root of both sides again, and we get x is the square root of 91. And again, you don't have to really get it out of your calculator. Just leave it like that. Right. So you've probably seen problems like this before, but I'd like to just show you where this wonderful result comes from and how it's proven. And there are actually like over 100 proofs of this Pythagorean theorem. And I'm going to show you the most common one. Usually it's the easiest to understand. So, and then don't worry, this proof will not, I know this is not a proofs course, and this will not be on the test. But just for your own curiosity, how do we prove this? Well, if we start with a right triangle, where the hypotenuse is C and A and B are the lengths of the legs, we can make like 4 copies of this and arrange them in such a way that we form a bigger square. Okay, so we have 1, 2, 3, 4 copies of this right triangle, and we've just arranged them in this way. We form this big square, And you'll see at the same time we've also formed a smaller square inside, this interior square whose side is C. And then you'll notice that we can just see that the area of the big square is equal to the areas of these four triangles plus the area of the middle square. Okay, and then we can just know what we know. We know how to compute the area of a triangle and the area of a square, so we can just set up an equation like this. So we can see that we have 4 times the area of the triangle plus the area of the inner square and that's equal to the area of the outside square, or the area of the big square. Okay. And then we can say, okay, well, what's the area of the triangle? Well, all these triangles are the same. The area of this triangle is 1/2 base times height. In this case, the base is B, the height is A. Okay, so this is 4 times 1/2 AB. The area of the inside square, well, the length of the side is C, so this is going to be C squared. And then the area of the big square, well, you'll notice what's the length of each side of the big square? It's A plus B. So this is going to be A plus B quantity squared. And then we can just do a little algebra. 4 times 1/2, that's 2. So this is 2AB plus C squared. And this is equal to, if we multiply this out, we have A squared plus 2AB plus B squared. Can't forget the middle term here, because now you can see these 2AB squares cancel out, or we can subtract 2AB from both sides. And we get C squared equals A squared plus B squared. Okay? So that's how we prove the Pythagorean theorem.